to Crash Coursable Chapter 20. My name is Maddie Motterhack, and today we'll be talking about water pollution. But before we can talk about water pollution, we have to go over the water cycle.
Starting with bodies of water such as lakes, oceans, and streams, water evaporates, sending water molecules up into the atmosphere. Those molecules, along with those that have transpired from plants and trees, experience condensation, where they turn back into liquid water, and come back down to Earth's surface in the form of precipitation. Then, runoff brings the water down under the surface, a process called infiltration and percolation. And this groundwater is naturally filtered through various biological processes. Then the groundwater is slowly moved back into lakes, oceans, and streams, and the process starts over again.
Okay, now you might be wondering, how does pollution factor into all this? First, let's talk about what water pollution actually is. Water pollution is any chemical, biological, or physical change in water quality that harms living organisms and makes it unsuitable for desired uses. Water pollution occurs from both point and non-point sources. As you may remember from previous chapters, point sources are single, identifiable sources of pollution, such as sewage plants and industrial factories. On the other hand, non-point sources are broad, diffuse areas of pollution which are difficult to identify where exactly the pollution is coming from. For example, urban streets, farms, and parking lots. These are very difficult to control and monitor. Unfortunately, the majority of water pollution comes from a non-point source, agricultural activities. Bacteria from livestock as well as fertilizer runoff seeps into the ground and pollutes drinking water, and they also find their way into our oceans and destroy habitats and kill ocean life. Other sources of water pollution include industry, where toxic chemicals are released and enter water sources, and mining, which causes major soil erosion and toxic chemical runoff. One dangerous effect of water pollution is its threat to human health. 1.2 billion people in the world have no access to clean water, and bathing in or drinking in contaminated water can lead to waterborne diseases such as cholera and E. coli. So now, we're going to narrow down our topic a little and talk about the problems with freshwater pollution, such as in streams and lakes. Streams naturally cleanse themselves and can recover from slight pollution through processes such as dilution and biodegradation.
Maybe you could
just say
dilution. Okay.
Streams naturally cleanse themselves and can recover from slight pollution through processes such as dilution. But when we overload these streams, divert them, and build dams to stop the flow, they have a harder time bouncing back. Developing countries have an even bigger problem when it comes to water pollution, because they don't have the money for water and sewage treatment plants, and they don't have the ability to enforce control laws. A lot of stream pollution in developing countries is caused by untreated sewage. Cities in these countries discharge about 80 to 90% of their sewage directly into freshwater lakes and streams, used for bathing, washing, and drinking. Developed countries have put water pollution laws into place that require industries to restrict or completely eliminate their point source pollution in order to avoid major incidents of drinking water contamination. That being said, developed countries aren't perfect. For example, in India, 40% of the population lives in the Ganges River basin and uses the Ganges River for drinking and bathing. Unfortunately, the river is extremely polluted. In fact, it is the 6th most polluted river in the entire world. Whoa, costume change. Okay. We're going to move on to lakes. Unlike streams and rivers, lakes don't have very much water mixing or flow, and that makes them more vulnerable to pollution. When contaminants enter lakes and reservoirs, they have nowhere to move and end up staying in the lake for long periods of time. Lakes do have a bouncing back process, but how many years does it take to work? We don't know. It wasn't in the book. Or on Google. Lakes do have a bouncing back process, but it takes many years compared to streams and rivers. Eutrophication is the enrichment of an ecosystem with chemical nutrients and is often a natural process for lakes. Though this is a good thing, human activity has taken it one step further and created cultural eutrophication. Then algae and aquatic plant populations skyrocket, taking the oxygen away from fish and other organisms in the lakes, decreasing lake productivity. Some ways we can prevent and reduce cultural eutrophication are: divert lake water to increase flow, ban or limit the use of phosphates and fertilizers and cleaning agents, employ soil conservationism to control runoff. Okay, moving on. Now we're going to talk about groundwater, which is far more widely used than you probably know. Common pollutants such as fertilizers, pesticides, gasoline, and organic solvents often seep into groundwater from various sources. For example, toxic arsenic contaminates drinking water in many areas where mining is common because soils and rocks are high in arsenic and drilling releases this arsenic, which then seeps into the groundwater. Now that lakes are all squared away, let's move on to oceans. Me and my friend here. Coastal waters such as estuaries, coral reefs, and wetlands experience most of humanity's pollution. Municipal waste all over the world is being dumped into oceans all over the world. And even though this dumping is illegal in many developed countries, it's still done in secret. Coastal waters also get some of their pollution from agricultural waste and runoff sewage. Those contaminants contain large amounts of nitrates and phosphates, and as we just discussed, these compounds help to kill off fish populations and decrease productivity. The areas in which this happens are called dead zones. Dun, dun, dun. Another pollution source in oceans is petroleum, and it's very destructive to oceans. For example, in 1989, the Exxon Valdez went off course, hit rocks, and released 10.8 million gallons of oil into Alaska's Prince William Sound. This ended up costing ExxonMobil billions of dollars in cleanup costs, fines, and lawsuits, and damages to 34,000 fishers and other Alaskans. The oil killed large numbers of seabirds, fish, and otters, and severely harmed the coastal and ocean ecosystems in that area. Even though tanker accidents are extremely harmful to the environment, they're not the largest source of oil in the oceans. The largest source of oil pollution in our oceans actually comes from land, leakages in pipelines, and urban and industrial runoff. Even though oil can be cleaned up after leakages and spills, an ecosystem has a hard time bouncing back after oil damages. Now that we've learned about the causes and effects of water pollution, we need to know how to deal with it. Since the majority of water pollution is caused by agricultural waste, many of the solutions are agriculturally based. Farmers can reduce soil erosion by keeping vegetation on all farmland and can reduce fertilizer runoff by planting buffer fields of vegetation between crops and surface water. Or they can use organic fertilizer, which eliminates nitrates and phosphates altogether. Another way to reduce water pollution is by sewage treatment. Rural and suburban areas use septic tanks. In septic tanks, household sewage and wastewater is pumped into a settling tank, where grease and oil rise to the top and solids fall to the bottom and are decomposed by bacteria. The partially treated wastewater is then released into the soil, which filters out pollutants and decomposes biodegradable material. These tanks need to be emptied every few years, and 1/4 of American homes are serviced through septic tanks. In urban areas in most developed countries, sewage is pumped through a sewer to a wastewater or sewage treatment plant. In these plants, sewage normally goes through 2 levels of treatment. Sewage treatment reduces already existing water pollution, but it doesn't prevent it. Fortunately, there are ways to do so, and by understanding the causes of water pollution, we can minimize its effects. Increasing the use of organic fertilizers, reducing the usage of toxic chemicals in industrial processes, and promoting soil quality to reduce runoff are all ways to prevent water pollution. Water pollution is a serious issue and should be treated as such. If there's one thing you take away from this video, remember that water pollution can't be solved by just politicians and the corporations. Citizens like you have the power to make a change. Today's quote: "It is a hard truth to swallow, but nature does not care if we live or die. We cannot survive without the oceans, for example, but they can do just fine without us." Roger Rosenblatt. Thanks for watching! Tune in next time for Chapter 21 Crash Coursable, where we learn about solid waste.